In this video, we're going to talk about quadratic problem solving, solving word problems that involve quadratic models. Before we begin, I just want to do a little bit of review here and work on factoring quadratic expressions that have the quadratic term, a number that's other than 1. So again, the first thing we want to check to see is, out of all three terms, the quadratic term, the linear term, and the constant, do they have something in common? Well, 7, numerically, no. And there's an x squared and x, but no x here, so there's nothing to factor out. So what we're going to do is set up our two sets of parentheses then and see what we can come up with. Again, 3 is negative, so we know that we have a positive and a negative. And 3 is prime, so let's just go ahead and put 3 and 1 in. Now we're looking at factors of 6 that have a difference of 7. So for 6, we can either use 1 and 6 or 3 and 2. If I put 3x here and 2x here, this gives me a positive 2x. This gives me a negative 9x, which gives me a difference of negative 7x. And that was what we were looking at here, is this was a difference. I knew that 7 was a difference because the constant over here was negative. So when this is a difference, the linear term is a difference. When this is a positive, that means these are both the same signs, then this number right here would be a sum. So we're all set. 3x plus 1 and 2x minus 3 are our factors. If this were to go another route and the instructions were to solve, this would have been set equal to 0, this would have been set equal to 0, would have taken our factors, set them equal to 0, 2x minus 3 equals 0, and we would have got x is equal to negative 1/3 and positive 3/2. Now we're ready to problem solve. We're going to start with what I consider to be a geometric problem. On this geometric problem, we have a pool that has a uniform width deck that's going to be built around the pool. Now, that's this brick-looking stuff right here, so I'm just sort of putting a little X because it's all uniform width. It's the same width all the way around. That's where you get these X. This X is referring to this thickness right here, and this X right here is referring to the thickness on the width side. So the pool area can be expressed as its length times width, which is 20 by 15, which is equal to 300 square feet. Now the trick in these problems is to decide what this other information that they've given you. So it says after the deck is built, it's going to be a total of 414 square feet will be occupied. So that means the pool plus deck area equals 414. And that's not always the case. Sometimes they'll say an additional 414 square feet. Sometimes they'll say double the original square footage. It's this additional area that's really the tricky piece to figure out. So what we have now is, a simple length times width equals area. And we want to look at the big picture now, the whole deck and pool itself. So this new length right here is 20 plus the 2x that's added to each side, because you have an x added to this side and an x added to that side for length. So that's going to be the 20 plus 2x's. Then, conversely, on the width, that's 2x plus the original 15 is equal to the new grand total area of 414. Take a minute, FOIL this out, set it equal to 0 because we want to get ready to factor or solve this by factoring, and when you do that, you want it set equal to 0. So go ahead, press pause, FOIL this, combine like terms, get rid of the 414, and then unpause and see if you get the same answer as me. So I end up with 4x squared plus 70x minus 114 equals 0. The next step in factoring is, of course, looking for something common to pull out, and we can factor out a 2, leaving us inside 2x squared plus 35x minus 57. and that's all set equal to 0. So now what we want to do is set up our two sets of parentheses. We know that the 57 is negative, so that's a plus and a minus. 2 is prime, so that's 2x and x. 57 does have some factors, so take a second and see if you could factor it. The magic factors are 19 and 2. Excuse me, 19 and 3. So 19 times 3 is 57. Well, that just works out too nicely. This will give us 3x. This will give us 38x, and the difference of 38 and 3 is the 35x that we're looking for. As I have it now, though, I'm going to get a negative 38x. So the actual factors we want to end up using here are 2x minus 3, x plus 19 equals 0. So that is the correct factorization. That'll get us 2 times 2x squared plus 35x minus 57. So we're going to take all of our factors, set them equal to 0. And solve. This one we toss out, it's not true. X is equal to positive 3/2. And then over here we're going to get x is equal to negative 19. Throw out that answer because for this problem it is geometric. Negative answers aren't possible. So x is equal to, and we're going to go to a decimal because it makes more sense in real life to talk in decimals. How wide is the deck encompassing the pool? The deck is 1.5 feet wide. Not x is equal to 1.5 feet, but the deck is 1.5 feet wide. Before we walk away from this, I think the key to all of these problems is to figure out the formula. What is it that we're talking about? We're talking about geometric problems. There must be some sort of area, perimeter, something, ratios, something going on. Otherwise, the formula is going to be given to you, and all you need to pay attention to is defining the variables. It's all about careful reading. Good luck.